Hi everyone, this is a definitive guide to React component design, but it's not just React. These are design considerations that work in any framework. And it's not just your design, it's also the architecture of your components. So it's really more like the definitive guide to architectural design. Hi everyone, I'm Kevin. I've got quite a bit of experience in the industry, but you probably don't know me. So you're probably wondering, what's my story? How did I get here? I always liked organizing. And my room cleaning method when I was a kid was to just shove everything away, put it in the drawers, put it under your bed, however I could get rid of it. If it was out of sight, it was clean. Then I ran into problems, so anytime I'd want to take something out, I'd have to take everything else out. I'd end up making a bigger mess just from trying to get something out of there because I cleaned poorly, and I realized that this form of cleaning wasn't sustainable, so I figured out a better way. It was to organize. And organization is really just Tetris. It gives everything a place. Because I properly organized my room, it was always 95, 99% clean. And if I took something out, I knew where to put it back. If I wanted to buy something new, I knew exactly where to put it. And if I had too many things, then I could reorganize until I found a better pattern that scaled with my behavior. I had board games and bought a shelving solution that could grow with my collection. As I got more games, I could put more shelves in. Even though it took up the same amount of space, I could put more stuff in there. But as I started selling those games, then I could take out shelves, and I could even take parts of it off, so I'd have less shelving pieces. This is all about organization because I planned for scale, and it allowed me to also scale down. Organization is also about getting rid of things. It's not just about adding new stuff. I'm also a developer, so what's my development story? This isn't the exact beginning of when I got my start, but I think this is when I really started making an impact in the industry. I wanted to make a game. And then I wanted to pay somebody or multiple people or anybody, honestly, anybody who would make this game for me because there was no way you're going to get me to code. I absolutely hated coding. I didn't understand it. Didn't know what was going on. And I just kept getting one thing after another that made it impossible for me to think that coding would be a reasonable career choice. I wanted to pay somebody to do it. And then I couldn't find anybody reliable. It wasn't that I couldn't find anybody. I had friends help me out with the game, but I ended up doing the majority of the work myself. And because of that, it's now on Steam. Yay. That's not the reason it's on Steam probably, but that's how I got my start. And now my code for that project, I look back at it and I can tell it really sucks. There are a lot of things that I could do better. So over time, I was able to improve some of the code. In general, I'm just able to improve my code as I go forward. So instead of coding badly and then getting better, I try to code it better from the start so I don't run into those situations. I've been coding for quite a while, and I don't mean just at work. I mean day and night. When I started coding like this for this game, I was working 40-hour days. So I'd get up for 40 hours, and then I'd sleep for 8 hours. And I would do this quite often. And some days I would have 16-hour days like normal people. Then I'd go back to 40-hour days. For the next 10 years, I was pretty much coding any waking hour I had, which was usually more hours than I should have been awake. I just coded day and night. At work, I would code, and then at home, I would code. I just got better and better at it. And I don't want other people to have to go through that. Once I got my kids, I was done doing that. But I still want people to learn from my experience so that they don't have to do the same things. How do we get into this situation? Why am I needing to do a talk on architecture? Well, you build what you know. So you build what's proven to work, and you don't want to change that. It's because you know what to expect and how to deliver and test those things. But what if what you know is bad architecture? This is the case where existing code is already acceptable because it got merged. Therefore, it's good enough to be used in production. Little did you know that code was rushed in and it was built just to work. Everyone knows how when you start out, you don't really know anything. And so you use the tools at your disposal to get your job done. Everything on the internet is true and accurate. Therefore, this is a reasonable way of adding code to your projects. Now, if you didn't understand what I said there, I'm joking. The internet is not all true and accurate. In fact, if you rely on the internet for your code, you're probably going to end up writing bad code and have tons of bad patterns. I learned that the hard way. But it was like this when I got here. Yes. By the time you get into a code base, it's probably been wrecked. So why do code bases get wrecked? That's because of deadlines. Oftentimes you don't have the time nor the authority to fix these bad patterns. So then why would you care? That's what we're going to talk about here. So we have our overview where we have why we care, and then separation of concerns. Then we're going to talk about bad patterns and alternatives to those patterns, and then actual solutions with real code that I've implemented in production that I think would be good patterns. Why would you care? Tech debt. So what is technical debt? Technical debt comes from having an insufficient design. Then why is tech debt bad? It's because you have to pay for it eventually. It's something you're accruing because you can't do it right the first time, and you're going to run into a situation where adding developers has diminishing returns. Do you remember this? Organization gives everything a place. If everything has a place, then you shouldn't be accruing debt. An insufficient design removes your ability to change or scale. What this means is that insufficient designs impede your ability to get work done, because change always happens and it needs to happen, and change relies on the capability to scale. Good architectural design solves the problem of long-term maintenance, it avoids component bloat, creates reusable designs that scale, then performance comes naturally, and you spend less time thinking about how to do something and more time feeling confident that you already have a scalable solution. That also makes it more enjoyable to code, because who wants to work on that legacy project? Now we're going to talk about separation of concerns, where we're separating things that don't belong together. And React components are the antithesis, because they have JavaScript, HTML, and CSS all in the same file, and those should be separate. Or should they? A component is actually made up of JavaScript, HTML, and CSS. Now, the CSS one's up in the air. This is the optional part of this. Typically, it does belong with your component. If you do have styles, they do belong with your component. These are all what make up a component. And if one of these parts is missing, then you don't have a component. Separation of concerns is really about thinking in terms of relationships and not categories. An example would be the test directory. Should that be a separate directory? No, because it's helpful to have tests with your components because they belong with the code you're testing. Tests are there to document code. So if your tests are somewhere else, your documentation is not where it belongs. Integration and end-to-end tests are separate because they test your application, which is at the root level of your project, not individual components. Individual components need tests with them, but integration and end-to-end tests would be application specific. So they could go into a different directory and that would be completely fine. When I'm thinking about separation of concerns, I think in terms of I am the component. What do I care about? What is important to me? And it's really not the component. It's also functions, hooks, context, state, anything. I'm thinking from this perspective. I am this thing. What do I care about? What do I want to output? What do I need to deal with myself? These concerns from separation of concerns are your API. What's important for your API? How does a consumer interact with your API? There's another guy I follow, Corey House. He put up 5 reasons why reusable components are harder to write than application code. His reasons were that we need to document all use cases, design for use cases that don't exist, and manage breaking changes. That's why writing reusable components is doing development on hard mode. Let's look at some HTML components, which I would call the definition of reusable. We've got a div, and it takes children and styles, and that's it. Now, you might be thinking div could take an onClick. That's for buttons and checkboxes and links and other things, not for div. Now, if you change the role of a div, it could do whatever you want, but a div itself cares about children and styles. That's it. Now, an input, what does this care about? It cares about onChange and value. Styles. Why are styles here? An input doesn't care about styles. But it does because it's an HTML element, and all HTML elements care about styles. Otherwise, this input wouldn't care. Let's make a React version of an input, like a picker component. Picker only cares about onChange and value. It does not care about styles. Why doesn't it care about styles? Because it is not an HTML element. Unlike input, React components don't care about styles. Maybe internally, but I'm talking about from the outside. What is a picker component? It is something that takes in values, or a value. It keeps track of its own internal values, and as a consumer, I absolutely don't care. So if it has any kind of internal values, they don't mean anything to me. I have no clue that's going on, and I really don't care. But it does notify me of any changes that happen from maybe user interactions or something else. So if a change happens, maybe to its internal values, I don't know, but a change has occurred, then it's going to tell me, and I can deal with that myself. Concerns need loose coupling. The 2 kinds of coupling you'll hear about it, tight and loose is the good one, tight is the bad one. So why is tight coupling bad? It's because all of these pieces are linked together. They're dependent on each other, and if one piece of that system is missing, the entire system won't work. That means each piece is now coming with its own baggage, and as a consumer, now I need to know about how all these little pieces intertwine and work together, where I don't really care about that. I'm just a consumer. I want to put something there and get it to work. I don't want to know how it works. I don't want to put it together myself. I just want to put it there and let it do its job and have its own system that it works with and not something that I have to deal with. This is a quote I found online. A tightly coupled system is purpose-built. Every custom deviation from the standard comes with its own resources and integrations. And what does this mean? It means you have to rebuild it from scratch when you're making changes if it's tightly coupled, because it is purpose-built. You might not think a lot of solutions are built this way, but they definitely are. Now we're going to talk about bad patterns, also known as typical component architecture. I know, it's a hot take. I get it. Not everybody understands this joke. When I told this, I got a bunch of like deer in the headlights looks. This is totally a joke, but I'm serious. Now we're going to talk about props drilling, also known as pass-through props. So with props drilling, you have a parent component. It takes in props, and then it passes those props into a child component. That child doesn't care about them either. So it just passes them on to another child. You know what? That child doesn't even care either, and it passes it to the next child. There was a project I worked on where the props were passed 6 levels deep, which you're like, okay, 6 levels deep, it's not bad. Oh, it was bad. And then there were 50 props. So now I'm trying to figure out, in this 6 levels of files, at what point are what props set to what values? And where are they coming from? Because there are 50 of them, and I don't even know which child component is doing what to those props. It was a big problem. So you might be thinking, this is good. This is the way to do it. You have the parent, you take the props, put it in the parent, and then you pass those to a child component. No. This is still bad. You should be using context instead. Props drilling, in my opinion, should instantly reject a PR because it violates separation of concerns. And you're tight coupling components that absolutely don't care about each other. And let's think of this in terms of a type system. When you have a type system, you have to now tightly couple your parent's types to your child types. Why does the parent care about any of these props? It doesn't. It's just passing them through to the child. In fact, the parent should have any or unknown or prop types.any or something to signify that the parent absolutely doesn't care about this prop, and it's just being used as a container to pass something to something else. But there are lots of ways around this, and context is the way I would get around that. Now, where would you want to use props drilling? Because there is a situation where you would want to use it. The only place that I would feel comfortable using that is third-party libraries. And that's because you cannot add a context to existing components. Therefore, it makes sense to pass props through into a third-party library. But it's also not ideal if you have to take in props and then type those yourself for somebody else, even though your component doesn't care about those props, nor do you own them. If you don't own those props, you shouldn't be typing them. Let the child component figure out the types. The takeaway is that at no point should you not be using context unless you physically cannot use context, like a third-party library. I really think you should be utilizing context everywhere in your React apps. If you're not using context, my opinion is that you're creating tech debt. And you might say, we do have context. In fact, we have one context at the top of our entire application. No, that's not the way to do it. Also, unless you're using something like Redux, you're going to be getting major performance penalties from using bare context in React. So if you use context without any kind of observables or anything like that, you're bypassing the way that React re-renders and most likely causing a ton of unnecessary re-renders. Another thing I've seen is context is used multiple places at the top level of your application. So it's not just used once, but you have 5, maybe 6, maybe 7, 8 providers at the top level. But again, these are all at the top level. Why don't you wrap those contexts in lower levels where they can be reused as you need more states? We'll get into this later. Another bad pattern is the class name prop. It's also not just the class name prop, but when you pass any styles, that would be bad architecture. And you're probably wondering, how is that bad architecture? We need styles and they're used everywhere. And I've never seen a React project where this is not the case. I have, but you might not have. With the class name prop, it makes me as a consumer responsible for knowing the HTML source code of your component that I am consuming. So if I'm going to render your component and I need to pass a class name to it, I need to know exactly how the HTML is laid out inside and what it's doing and where it's wrapping and what kind of things it's playing with. Otherwise, I cannot pass it a class name. As a consumer, I don't care about the source code of your component, nor should I need to know about it. It is not my responsibility. It is your responsibility. Remember, we're thinking in terms of I am this component. So I am a component that is consuming another component. Do I care about your source code? No, I don't care about your source code. It's not my responsibility. Needing to know about that source code is tight coupling. Therefore, class name is tight coupling. And class name is also pass-through props. We just talked about how these are bad, so you shouldn't use it for that reason. You might be thinking, I need theming in my application. How do I theme stuff? Because each use of this component needs to be slightly different or something like that. You've got something called context, and you can pass a context with theme information into those components. And that way, the context can handle the contract and not the class name prop, which is tight coupling. In the context, when I'm saying context, I'm not saying put H1 and H2 and div and span and all that stuff and paragraph tag and whatever in your theme. That's not what I'm saying. I'm saying name these things with semantic names and allow the component to figure out what it wants to do behind the scenes. But you're not going to be exposing or needing to have other consumers know about the HTML source code of your component to be able to interact with the styling of it. Let's look at an HTML button. What does it care about? Well, it cares about children, onClick, and styles. And the only reason it cares about styles is because it's an HTML component. But onClick and children, this is pretty good, right? Buttons do care about a few other things, but in general, this is all they care about. And if we look at an HTML button, what does it care about? It cares about children and onClick. And that's it. No styles. This is a good pattern. Margin is bad architecture. You don't want your margin to be exposed outside of your component. So if you have a div and there are components in that div that have margin, as long as there's no top, bottom, left, and right that's being exposed outside of that div, you're fine. But if the margin is exposed, like you have a button and it has margin on it, that's a problem. If that button has margin on it, then you as a consumer can never control it. If the button didn't come with any margin, then you can be in charge of styling it. If you're going to put margin in some kind of renderer of a button, then that would be something like a button group, where it knows how to render multiple buttons, and it would provide the spacing or gap between those buttons. But it would not expose any margin again. So there would not be any margin exposed to a consuming component. It would just be internal between the buttons, and only between the buttons. We can look at a BoxSpacer component. Now this is on the same topic, but it's a little bit different, where these components would handle CSS margin for you, but they don't go inside your button. So this is another example of you don't want to put any kind of component in your button that controls the spacing outside of it. The button doesn't care about that. The stuff outside of it does. If I'm consuming a button, I want it to look a certain way. The button doesn't care about how it looks around other components. It only cares about itself and how it looks inside its little box. If you do have a box or a spacer inside your button component, the problem is that's pass-through props. You're saying, I have a button and there's a box wrapping it or a spacer in there, and I have to pass properties to the button that really go to the box. Now, anytime I see this button, I have to know that it has a box inside of it. Even though in the documentation, there's nothing about a box, right? Because you're only going to get button properties in your documentation. Now I need to know there's a box there, and I need to pass the properties to the button that I would normally be passing to a box instead of rendering the box myself. This is where you get into this pass-through props again. Pass-through props are bad architecture. Therefore, putting something like a box or a spacer inside of your button means that now you're passing props from your button into some other component. Again, you want to use some kind of button group to add those gaps. Don't have the button responsible for any of this, because if I'm in the button's perspective, I don't care about that. In fact, I don't even know I'm being rendered in an application. I am just a button. Options is a prop I see quite often. It's not always named this, but it is this kind of a prop, and it is usually an object or an array. Now, an options prop bypasses React's prop system. It might not be memoized, especially not for inner props, and it makes consumers responsible for setting defaults, not the component that actually has the prop on it. We'll get to the options prop later, but right now we're going to go into render props. Render props are when a component accepts children as a function. These are bad children. Render props require a lot of boilerplate, which is why they're not a good pattern. If there are any changes necessary, now have to be represented in multiple places. It also makes your code harder to read because the same thing is written in multiple places, which also means you have the possibility of making mistakes. Render props are also impossible to memoize, which means they can cause performance problems in your application, especially React apps where memoization is the key to performance. If you really want to get by using render props, you should really use hooks and context. Those are the new technologies that override the need for having render props. Now we're going to look at some alternative patterns, like component properties or props. Now props are a way to modify a component. If you're setting the properties of a component, you can alter the look and behavior of them. And in this example, these are properties, and these are where I'm setting those properties in my JSX. These are arguments to a function. It's the same as passing props to a component. A game's options menu is a set of properties, and you use those properties to configure the game. Props is a way of configuring your component, and is a way of configuring other things. Context is a way of sharing properties between components. These are contexts, and we're getting properties out of those contexts. Therefore, context is just shared props. Window and global are also contexts, which means they're shared props. Singletons are shared context, which also means they are shared props. And singletons manage your data. The more you know. Context is this old concept. It's been there long before React. In React, it's actually been there since the beginning, or around the beginning, at least since I got into it. Now it's referred to as legacy context, and it was used with Redux, which is also shared props. So what were we talking about? We were talking about props. And we're going to look at another set of props, the options that I talked about earlier. Options is just props. We have this component that takes options, and in this case, it's an object. And this object is really just properties. And you could spread those properties onto the component, and each of these properties in here could have been a prop on the component. I can understand if you're passing data, but if you are passing data in one of these objects here, it does tightly couple your backend API to your component, and your component has different concerns than your API. So I would consider this a bad pattern. Here's another example of bad props, where you have multiple sets of individual props. The thing is, yes, you can spread one of these onto the select, so you can, whatever's in here. Let's say it has some text or something, and you spread that onto the select, fine, but you can't spread two of them. How do you do that? You have to have an array. How do you get around having multiple sets of individual props that you pass to a single component? You use children. Value, that's a prop. Text is a prop. And now that we have children instead of options, select doesn't need to know about its children. In fact, it can render whatever the heck it wants here. It does not need to know about them. We can even render something completely different inside the select because it's just children, like this option heading. Now we can put headings in here, and we didn't even have to modify the select component. I can just randomly add this here, and therefore it renders. This is really great. And because we know these are props, but so are children, that means these are props too. So components are also props to your select input. It's just like how HTML works, except HTML has a built-in renderer for options, and therefore you cannot do something like this, but you can put option groups in there. Children is props. Because children is props, that means you can modify a parent component using children, like we just showed. And with context, you can even set the props on a parent with children. You add a child. If it reads from context, it can modify the parent. That's crazy, but also the parents can read properties from their children, which means you can modify a parent by just changing the props on children, because parents can read the props on the children. Now, that might not necessarily be good architecture, but there are use cases for it, like clone element, where you read the props on a child, you take what you need and modify some things, and then you pass them back into the child. And I really do think that clone element is an overpowered function in React. It allows rendering children with new props. In fact, if you didn't know this, you don't have to render every child element. You can filter them out. You can render no child elements and just take the props of what was there, clone one of them, and put new props on it. You can do whatever you want. It's crazy. The important thing to understand is the clone element is very powerful. You have to be careful with how you use it, but it replaces render props, which is so cool, and it removes boilerplate. Oh, that's great. I love removing boilerplate. That means there's less code to write, and it's functional programming composition. You can give a component an input as children, and with clone element, you can get a different output, which is a copy, but not the exact version. So you're not mutating the children, you're creating a new child and then rendering that out as children. Clone element does have a drawback, and the drawback is that it's not clear which props the parent is reading or writing. And this is important, but you can get around it with contracts. One form, for instance, is a form library that I made. It uses clone element extensively, and this is why it has such a clean and composable API compared to some other well-known libraries out there that you probably are using today. And if you're wondering about hooks, how does hooks compare to clone element? Hooks has a lot of drawbacks. For instance, it has a similar amount of boilerplate to render props. Why is that? Because hooks replace render props, but they just move render props to the parent level. There's a lot of other stuff that hooks are doing, but that's the main difference, is that hooks are render props moved to the parent level, which means they add a lot of indirection. So instead of the properties that you originally had with render props in line where you needed to see them, now they're at the top of your component somewhere else, completely separate from your code, which in a lot of cases could be a good thing. Sometimes it's not. Because hooks are at the parent level, they cause re-renders at the parent level. This could be a performance problem depending on how you built your app. Parent components also become messy when you have a lot of hooks, because you have lots of hooks. There's a lot of stuff in there that's unrelated to the view itself. And if you put the hooks in separate child components, you get around the re-rendering at the parent level, and your parent doesn't become messy. But now you have all these extra components that are literally there to just wrap one piece of logic. The only reason you're doing that is because you have hooks. You can avoid that altogether, which makes your code easy to compose. If you've ever heard of something called compound components, this is a pattern that uses clone element. Now, I didn't come up with this, although I thought I did. This was originally done by Ryan Florence in a talk that was from 2017. Now, I thought this was super cool. I didn't understand it at all when I first watched this video, and I didn't remember it using clone element until I made this presentation, because I went back and looked at it for information that maybe I should look into this compound components thing and see if it's anything like the method that I'm using. And it was. Although mine's a little bit more advanced because React has come a long way since 2017. For me, my design philosophy is called children first. It means children before props. I think of it as a design principle. And if I stick to this principle of children first, my architectures will last longer. That means I can avoid tech debt. And that means things can scale. And as a project goes on longer and longer, it ends up speeding up rather than slowing down. Let's look at some real solutions. This man is a debt collector. It usually becomes my job to fix things that are broken, even if they have nothing to do with me. I hate having to worry about things that are unrelated to my tasks at work, because I've got something that needs to get done, and it might be really simple. But then, because of this thing over here, that means I can't get my work done, so I gotta go fix that. Oh, but that thing, because nobody's touched it for 4 years, causes this other problem, so now I gotta worry about this other team's work, because it's going to be affected by my work. I needed to fix this thing to get my work in. I hate that. I have to collect the debt. I'm also somebody who builds systems. People come to me with questions of, how do I do X in this system I built? It's easier for me to tell them, hey, it's already capable of doing this. You just have to build this thing yourself. But I have allowed you through the API to extend it as necessary. One thing might be children. So if I have children first design and I build something like an accordion, I don't want the styles baked into the accordion because you can't change them. But if I allow you to maybe consume a context and you can change the accordion yourself and put your own button there, then hey, problem solved. Let's make a children first accordion list. What would that look like? In fact, what is an accordion list? So an accordion list is a component that renders children. Not accordions, it renders children. It just happens to be rendering accordions in this example. What do these accordions care about? They care about being expanded or collapsed. That's it. They don't care about anything else but being expanded or collapsed. In this case, the accordion should have children as well, but I'm not going to go into that yet. So right now we got this accordion list. Okay, let's think about this. It probably has some logic, right? Because it's supposed to maintain which accordion is currently open. But the thing is, it doesn't know anything about accordions. It doesn't know about children. So through context, we can provide a function for the children to notify the accordion list when they're currently open. Now, this is the shady part of context because you don't know anything's going on here. You don't realize that there's like this accordion, it's talking to this accordion list behind your back. You have no clue. You don't even know if it's cheating on you. But that doesn't matter because you don't care about it. You're not responsible for these. You just want to render this guy and render these guys and have them manage their own state. You don't want to care about that. Let's think about styles then. The accordion list, it has the word list. List makes me think UL, some kind of unordered list. And yeah, it does have a UL. And then I'm thinking like LI, right? You have to have a LI and a UL. Those are tightly coupled HTML components. So where's the LI go? Obviously, it goes in the accordion. The LI goes in the accordion list. Why would it do that? Why would you put an LI inside of an accordion list? You're probably thinking, like, how would you do that? That doesn't make any sense to me. You probably even have more questions now because the accordion list does not handle rendering. It shouldn't, actually. In fact, it should just handle logic. So in this case, it should be called AccordionList provider. But what's interesting here is that I put a list component in here, and I took away one of the accordions because I ran out of room. And list has the UL and LI. AccordionList is a provider that renders children. List is actually what has the UL and LI. That prevents a lot of problems. The reason why it's important to separate this list from the accordion list is because the logic and the styles don't belong together. But that doesn't matter. Like, just put it in there and it'll be fine because I have a small app and nobody cares. Except that you do care, because when you render multiple accordions, what you're saying here in this previous example I had is that the list has to be there to render multiple accordions. That's what you're saying, because it contains UL and LI. What that means is, if there is a problem where you don't want these accordions to react to the state in the accordion list, you want the accordion list to basically be shut off, but you still need the UL and LI, then you need to add a prop here to shut it off. You need to say, hey, I want these accordions to open separately, and I don't want them to be controlled by the accordion list. You need to tell the accordion list off and make sure it doesn't call you back. You guys had a relationship, but you're not in one anymore. The accordion list needs to just get away. And without having to sign some kind of paperwork, you basically need to pass a prop to the accordion list so it gets it. The easiest way around that is just making a separate component, a list component. If you need to render multiple accordions in a list, you can wrap them like this. And that list component can be anything. It can be any kind of UI you want. In fact, you can switch it out with a menu list or some other kind of list. I don't care, but it can be any kind of list. And if that list contains a UL and LI structure inside of it, then your accordions can render in that and they don't have to worry about accordion list. And if you don't want them controlled by accordion list, then instead of getting a restraining order, all you got to do is just not have the accordion list there at all. Problem solved. And this is what that looks like inside. We've got React children. Okay, what's this children thing? I've never heard of this. There's this children thing inside of React, and you can use it. You can call toArray on it and pass it children, and it makes your children into an array, which you can now map. And because you can map them, you can take each child and wrap it in an LI. So now this list component is children first. It is able to render a number of children, but not have a clue what they are. It absolutely doesn't care what the children are. It just knows that it has a UL and every child has to be in an LI. Now, if you want to put multiple children, like a header above your accordion, you can do it. You just have to put a div there first and then put both of them inside of the list. But they will always be wrapped in an LI, which is fantastic. This avoids tight coupling of styles in HTML because the accordion doesn't have to have an LI, which means it can render by itself. You can optionally have a list wherever you need it, and it can include whatever styles it needs. If you've ever had a situation where you need display flex, and display flex would go like on the parent, and then in a child element, you need to put flex 1 or something like that. In a lot of cases, your children don't even know they're in a display flex container because they're rendered in different components. If that's the case, you're tight coupling things. You can get around that tight coupling by saying, I control the UL and the LI. Therefore, if I put a display flex here, I'm free to put a flex 1 here. I control all of the rendering. That's okay. That is not a violation of separation of concerns. So this is good. Now, what about text input? Can it be children first? And you're probably thinking to yourself, text input? What do you mean children? Text input has no children. But it does. Because in quite a few projects I've worked on or seen, text input, this one right here, takes some form of options as a prop for add-ons. The prop could be named add-ons. Doesn't matter. So how would you handle add-ons but make them children first? Now, this is really interesting because it's a really neat use of context. This is how you might do that. So you have these components called text input add-on left and text input add-on right. They can have different types, like one that's seamless, so it matches the text input and it just sits inside of it. Another that's a border, which means it looks different from the rest of the input. And then you can pass some children into those. These children can be sent through context into the text input. So the text input can render the add-ons where it needs to because they're children. Isn't that crazy? You can pass children to children and then take those children of the children and put them into the text input and render them wherever you want. And really, this is not just a text input component anymore. Because this is all happening through context, this is actually a text input provider component. But we're not going to name it that because that would be weird since you can render it without children if you wanted to. That's a really good example here of a text input. Now, you could also wrap all of this in a text input provider. And if the provider exists, then you do something with these, and then this is importing from the children. Yeah, you don't have to have children in text input. I'm just using this as an example. Honestly, the right way to go about it would be to have a text input provider that wraps all of this. So you can optionally pass these not as children of text input, but as children of text input provider, and then text input would just get these children through context. That's another way of doing it that I would probably prefer. This is just a crazy way of thinking about text input could take children too, which is something you would never expect. And now it's all self-contained. Let's make a range input. It looks something like this. What are we looking at? This is a children first range input. And why did I write context as shared props here? Without context, this wouldn't be possible. You actually cannot do this without context. And in fact, if you're using regular React context, this is actually not going to be performant. You need some kind of observable to make this work. Now, when I have built one of these before, which I have built one of these from scratch. Now, you're probably wondering what's a range input. It's like one of those little sliders. Like you click on a little dot and you pull it across. And mine even had some cool functionality. Like you click it and it like grabs onto different things. Although the algorithm was static and it wouldn't like let go. So it wouldn't just be like, no, I'm letting go. It would always have this like magnetic pull to certain markers. And that sucked. I could probably fix it today now that I'm aware of the problem. But before I was like, oh, this is just how it's going to be. I didn't even think about it. To put this into perspective, let's look at this. So we got a range input. This is really range input provider, and I should have named it that. And this is a track. Okay, so we've got a track. That's a line. And then we have a bunch of markers on that track. So we're going to loop them ourselves. And then we've got a handle. And the handle is a little thing that you're clicking on. And now you can make the handle whatever you want. You can make it a heart shape. You can make it a star. You can make it whatever you want. Great. The one problem is the markers. Okay, so these markers have to be spaced a certain way. And if you leave that up to consumers, they're not going to know what to do with it. So this is where it might be nice to have some kind of range input marker group where you can feed it some information. But the markers array might have that information inside of it. It might say where each marker goes, what its placement is. If that's the case, great. Put it on the input marker, no big deal. But if they need to be evenly spaced for some reason, then it is best to do that in a surrounding component, which I don't have here, but it would be best to do that in a surrounding component. Now, when I built this originally, I built it all in the range input. So you just have this component called a range input component. And then inside of there, I had the track, the markers, and the handle, and I controlled all that stuff. That also meant I had a lot of props. I also had to pass props into these various components. So there was a color prop that needed to be passed in here and here. I had passer props. If you want to change the color of the range input and you're using some kind of theming, you could do it out here, or you could do it with a separate theme, and then you wouldn't even have to worry about it at this level. But what's important here is that if I passed a color prop here, I can pass it to all of these through context today. But the way I had to be in charge of passing the color to each of these components myself. It could be that you want all these different colors. The way I built it before didn't allow for that kind of changing. I had to have a color prop here, and I had to control the color of where it went and how these got colored. I also had to control how they looked when they weren't colored, like when they were inactive, or when you didn't have your hand on it, or when somebody hovered over it. What does it look like? I controlled all of that in the range input. Even though these were still separate components, I had to pass props to them. If you think about designs differently, children first, they'll scale more. The one that I had, you could not scale it. If you wanted to change the color of the little thing you're dragging from green to black or something like that, you couldn't just add another component here. You literally had to go into the range input component itself and change that color. That was tie coupling. It's bad. If I built it today, I wouldn't build it like that. Another great example is a star rating component. And you're probably thinking, this is so simple. I don't understand. Children first, what? Maybe putting some icons into it. What are you doing here? I was asked to make a star rating component. And this is what I built. It is display only. And that was because those were my requirements. I had the requirements of make it look like what's on the screen. Nobody told me you can click it to update it or anything like that. So I built this and I was like, great, problem solved. This does tightly couple your styles, your icons, and your amount. Everything is in the star rating. In fact, it has to be stars because that's how it's been built. And it's using icons, and the icons only have half steps, and you can't do anything other than half steps. These are all requirements that maybe were needed, but I didn't build for them because I just looked at the UI and I was like, this is what I need to build. That is not a scalable design. This is very not scalable. Oh my God, if I wanted to do one with circles, I would have to build a whole new component that handled it. And it wouldn't work exactly like this one, unless maybe I could move some logic out into hooks or something. It's just so much more stuff that I have to handle. When I'm thinking about the star rating, it's more like, what was I asked to build? I was asked to build an interactable range input of images. So it's a range input of images. I built one of those before. Now, star rating is an implementation of what they're asking me to do. So if we look at a rating component then, this is more generic. Some friends of mine were seeing me do this presentation. They were like, hey, how would you do this? here's how I would build a star rating differently than I did before. I was thinking through it. I was like, okay, I guess you could take an icon, and so just take it as a prop. I'll still render them though. I'm managing the rendering of the icons and all that, and the on change and hover and all these other values that now, and then they were saying, well, what if you had like 2.7? And I was like, oh, 2.7, crud. I can't do that. Oh, here, I can provide a stepping value. And maybe like the max icons here is the maximum values or something like that. The problem with this is that it's still tightly coupled. There is still tight coupling here. And that's because I'm keeping track of the icon and rendering that in the rating. Like, why isn't the rating taking children? It's not children first. In fact, now I have to maintain the number of icons. Like, I could just count the number of children. I could do children.toArray and then get the number of children. That would be great. Now I have the max number that I have to compute. The stepping value, well, that's still important. So some of these are still important, but also this value is relative. It is relative to the max icons. But instead, maybe we want the value to be based on 0 to 1 or 0 to 100, something more scalable relative to the data we might be getting. So I wanted to make it more generic, and I thought about building blocks. And if we're thinking about building blocks, we're thinking children first. And so now we can get a generic rating component. And we removed anything to do with icons. So they're all children. The icons are all going to go down here. Now this is a range input. It's not saying range input, but technically it is. And this is now a logic container. Rating is just a container of logic. And it's like, hey, I'm going to render children. Children is going to be rendered. That's the end of it. And I might render some kind of color over the children. That might come from rating. It might have some kind of rectangle that resizes and has some kind of mask that changes the color of these images or icons or whatever is inside its children. It doesn't care. It doesn't know. Now the value is based on 0 to 1, which is great because that gives us a different way to represent those values generically where it's not based on children. The stepping value is still important because you need to know how you're stepping from 0 to 1. In this case, it only has 10 steps. So there are only 10 possible values. Here's another thing, has selection. So you can allow now from the logic side to see if these are clickable inside. That's great. Through context, now we can render children. This is a very crude example of how you would render children. You'd actually want probably some kind of context wrapper for each one. In this case, I can just render a bunch of star icons. I got 5, so I'm going to fill that array with 5 star icons and pass that as children. There you go. You can make a children first rating that then takes a random set of icons. I don't even care what they are. One could be a star, one could be a heart, one could be a circle. It doesn't matter. It has nothing to do with me. I created the building blocks and I can put whatever I want in children. Now I don't have to refactor it when I get new requirements. In fact, I could build the original star rating component using this children and that rating component. I can now build a star rating component and then use that wherever I wanted to. It's crazy. This is more generic, but it also allows you to derive the original version with just the star rating component and a star count. It allows you to derive that from this code, which is why I think it's super valuable. We built these building blocks that allow you to make something else that's way simpler. And you could make that star rating off of this. But if then they ask you to use circles, then you can just make a new component using the building blocks without having to rewrite all your logic and how everything works and the styling and everything else and make 50 different hooks to make it work. You don't have to do any of that. It's already built. You just have to create a new one with a different icon in it. Easy. Now I'm wondering which you prefer. So there were 3 different versions that I showed. The original one that was star rating took a star count. Then there was a rating one, which was still tight coupling, but it was far removed from the original, but it allowed more modifications. And then there was the one that allowed a lot of changes. You could build the first one off of it really easily. And in fact, you could build multiple iterations of anything that you want at that point. And I'm wondering if you would feel more or less comfortable with the generic version. Now, again, you don't have to consume the generic version more than once. If you want to make a star rating that's like super simple, you could just make that one, but you could also make the generic one and then create the star rating component off of that and never touch it again. Your unit testing would be a lot simpler because it would already been tested through the rating component. So I want you to think about that and think about which one you prefer. Feel free to comment below. No. Is this over-engineering? Well, over-engineering is when you build something that wasn't asked. So we need to think about what we were asked. We weren't asked to build something that allowed for a random number of items or the ability for the items to change themselves. Those were not part of the requirements. And you could say, I shouldn't build those in. And yeah, you don't need to. It was fine. Build it as simple as it needs to be. But keep in mind that when the next person gets to the code, they're going to see what was already merged, the existing code, and they're going to build off of that. They are not going to refactor the entire thing and make it the version that I was showing. So when they want circles, all of a sudden, no one's going to build it with this architecture that allows scaling. They're going to build it with a prop where you can pass in a star or a circle. Or they might be a little bit more adventurous and allow you to put any kind of icon in there. Thankfully, this is how you get into these situations of bad architecture. You're thinking, what do I need to build today? And then somebody else comes in and says, what do I need to build right now? Because I have one ticket and I'm not looking at everything. This is really interesting because there's a trade-off here. Now, rating is an extreme example, and I want to make that very clear. I'm showing you this as the most extreme example I can think of because ratings hardly ever change in your application. Really, what you should be thinking about is accurately identifying what you're being asked to build and what it's going to cost the company through tech debt to make changes in the future, depending on their needs. And a lot of companies have been at everything changes. You're always constantly making changes, but the rating components, I'm like, this probably never gets touched. So this is an example of probably over-engineering, but maybe not. It depends on your needs. If I have a bunch of companies that use my component library and they're all different, this does not seem too crazy then. In fact, doing it the way I did it is probably the correct solution, not the over-engineering version, because it's scalable. It allows them to change it to however they need. It allows customization. In a lot of cases, customization is actually what you want from your component library at a company because every designer and every UX needs something slightly different. You need to allow for that customization. You don't have to build it in. You just allow for it so that somebody can build it in as necessary. Over-engineering makes a solution more complicated than it needs to be. And in this situation, or not with the rating, but in the other examples of children first, is it more or less complicated? That really depends on your needs. And in a lot of cases, you do want it a little bit more complicated up front so you don't pay for that tech debt in the future. It immediately becomes tech debt as soon as you cannot change or scale. The design was insufficient for your needs. Is a 1,000 line component with 3,000 lines of unit tests over-engineering? Or small reusable building blocks? I would think of this as like the star rating component, which it's not. Okay, it doesn't have to be that long. Could be way simpler. But in a lot of cases, that's what this is. This is one of those components, like the range input that I built a long time ago. It was 1,000 lines. And oh my God, the unit tests. You're building all this into a custom purpose-built solution because it's tightly coupled. Or you can build these small reusable building blocks that, yeah, you have to test them and you have to build them and make them generic. But over time, as you're using those building blocks, your code should start being built a lot faster. You can build applications much quicker because you've got these building blocks. And I've actually done this at multiple companies where I built tooling that allows us to scale, but it takes time to build that tooling. Once I built it, you can see the scaling. It's exponential. In a lot of projects, the scaling is logarithmic, meaning it goes close to 1 and kind of just sits there. You can throw 100 developers at the problem and it won't make it any faster. And that's your velocity. You can't go any faster than that. That's why I like reusable building blocks. Rating was an extreme example. I did that on purpose. Now let's make a typical accordion. What does that look like? It's an accordion. Okay, it takes content. This is a typical accordion. Now you have no control over it in this case. And now it might pass some props and then you can control it. Okay, great. But what I mean by no control, this accordion has a button in it. What if you want to change it? What if you want to change how it looks? Well, now you got to pass a bunch of props to the button through the accordion. That is pass-through props, also known as props drilling. You don't want to do that. So this is effectively not controllable. And if you want to render a different kind of button, either you need to program that into the accordion or you need to build a completely fundamentally different solution to this problem. We're going to look at what that looks like with hooks first, and then see what that looks like children first. I want to show you this to show how similar these are going to be, but how much better it is when you have children first. With the hooks accordion, you have to control everything yourself. You do have control, but you have to control it. Now, the accordion is just the content element that is expanded or collapsed, and the button is the thing that you click to toggle it. But with the hook, in most projects, you will never get a friendly hook like this, okay? You're gonna have to rebuild this from scratch, every single component. I am hard-pressed to find people create reusable hooks like this where, oh, it gives you is expanded in the toggle accordion and you're just good to go. Normally what I've seen is that people will rewrite this logic in every single component. In fact, with Redux and reducers, I would see people rewrite reducers for loading indicators. You would have maybe 15 loading indicator logics or more in your application, when that could have been just one reducer. And in the same case, it could have been one set of hooks. So if you were building Redux that way, I would assume that you're building hooks that way too. Just a guess, because I would be hard pressed to find people creating like reusable hooks like this. Now, if you're thinking, hey, we use reusable hooks like this, great, okay, but still tight coupling. I'm going to explain why. This toggle accordion goes here. Okay, this is expanded, goes here. I have to maintain this myself. I have to know to pass this into the on-click of a button. Every time I render an accordion, I have to manage this myself. This is not my responsibility. As a consumer, I want to render an accordion and yeah, a button, but I don't want to control how they work together. Why is that my responsibility? I don't have to do all this stuff. This hook could be integrated inside of the button and the accordion together, and they can maintain their state together. But how would they do that? That's the interesting part of all of this. How would a button and an accordion be one and the same? How do we do that? I want to show you a modal built with hooks, and I want to do this to prove a point. Do you notice anything here? Maybe the fact that it's almost identical to the accordion logic. Okay, we'll get back to that. Now let's make a children first modal. What is that going to look like? Okay, what about accordion? We'll get to it. We're going to concentrate on modal because a lot of people use modals and a lot of people are familiar with them. Less people, I would assume, are familiar with accordions. This modal looks fundamentally different from what you've probably ever seen. The reason is it's children first. This is a modal trigger. There's a button being cloned in modal trigger, and the modal trigger is adding an on-click to the button. Now, if the button already has an on-click, it can wrap that in its own function and call the on-click on the button once it's done doing its stuff. Fine. Just assume that kind of stuff is there because when you implement this, you want to be doing that kind of stuff. This is interesting because I don't have to maintain an isExpanded or an onClick. You're probably looking at this and saying, I left off all the props. No, this is it. This is how you get it to work. This is right here, a children first modal. It's done. There are no props. Yes, you can pass props if I needed to. In this case, I don't. I have a button. It could be an HTML button. It could be a React button. It doesn't matter. You click the button, it opens this content in the screen in a modal. It looks magical, and it is, but it allows you to have any trigger you want and any content you want. That's what's really important here. This is a trigger. This is the content. You can have anything you want in these spots. That's crazy talk. I don't have to maintain this now. Yes, I have to know what kind of button I want, but that's my job. As a consumer, I want to know which button I'm putting in there. I don't want to have to maintain how it opens and handles a modal. I don't want to make that connection. I just want to wrap some components there and have the components maintain their own state and figure out whatever magical stuff that they got to do. I want to also make it clear too that this modal provider is going to wrap every single modal. You're not going to have one of these at the top of your app. You're going to have one for every single modal. You're probably thinking, okay, that's a lot for just a modal. You're never really going to get in a situation where you need this. You just put the button in whatever, and that's so much simpler. But I'm going to show you later that once we build building blocks out of this, it's going to be way better to do it this way. You'll see. We do have a problem though. What if we don't have an on-click on our button, right? That's bad. If we don't have an on-click on our button, this isn't going to work. This is cloning and expecting an on-click property. We can fix that by creating a special modal trigger. It's a new component that wraps your modal trigger and translates some props. Now, you could do this inline. You don't have to create a separate component, but I'm assuming that if you have a button at work and that button uses onSelect instead of onClick as the click event, then you would need to do this once in your application or in your component library and then expose it because it doesn't follow the standard of using an onClick function. Okay, that's fine. Now we've fixed this problem. It is more versatile. Modal trigger, because of this translate props function, allows you to translate anything that was coming from here into whatever you want it to be for your particular component needs. I've actually had to do this kind of translate props before in a production application because the component library had different properties than would be normally expected. And so I had to do something weird. That's normal. That's not bad. And I only did it once. From then on, we just imported that special one anytime we needed it. There's another problem though. What if one modal opens another modal? You can't have a provider inside of a provider. If you do get in the situation, you know what the problem is. You'll know exactly what the problem is, but here's the solution. All we need to do is add a name prop to each modal provider, and now they're synced. Now you're probably thinking, okay, haha, magic. How does this work? Because there is no provider linking these providers, right? Yeah, and that's up to you to solve. I always solve this with JavaScript events, native browser JavaScript events. That allows these two to be synced so that if there's a change made here, it does then change it here. That's fine. That is a way around this. You could do this with Jotai Addons. They would honestly work really well. If I wanted to use a third-party library, that's what I would use. If you wanted to use Redux, you could use Redux. It doesn't matter. Really, you solve this problem however you need to. This is the solution. It does fix the problem. It does allow one trigger to open another target. That's very valuable because now in one modal, you can open another modal. You could just wrap that trigger in a different modal provider with a different name on it that matches the name of something else. And sometimes you might wind up in a situation where you need to open the modal programmatically. Like you've clicked something or an event has occurred, and now you need to open it programmatically by calling a function. How do you do that? The exact same way. In fact, this use modal hook that's taking a name might actually be what's used inside the modal provider itself. So now you're using the same logic that's used in the provider outside of the provider. That's fantastic. You're essentially making your own modal provider this way. It's crazy. I know. Here's a closed modal, here's an open modal function. Bam. Problem solved. So now that we've solved all of those problems, let's make a children first dropdown. Okay, so wait a second. This looks like vaguely familiar to me. In fact, it looks extremely familiar, almost identical to the modal, except for I've renamed everything to dropdown. That means modal, dropdown, and accordion are all the same. And it's not just these. They're like drawer and other things. They're all the same. And if we really think about what we were asked to build, we were asked to build a component or a set of components where they have a button that hides or shows content. That's all we were asked to do. I want a button that hides or shows a dropdown, or hides or shows a modal, or hides or shows an accordion. In that case, it's more like expanding and collapsing it. That's interesting. They're all the same. I was asked to build the same thing 3 different times, or 4 if you want to count drawer, or 5 if you want to add tooltip or something else. I've built these all individually multiple times in my career and never realized that they're exactly the same. I have, but never really figured out a good solution because I'll always get one ticket or one task, and that task will be build a modal. That task won't be build a modal and something that also works for the accordion and something that also works for a dropdown, because most people aren't asking for those things. They want you to do one set of tasks. They're not wanting you to look at the 10,000 foot view and build something that works for everything that's coming in the future. Now, I typically like to build everything that's coming in the future with one thing today because it makes my life easier. And then again, exponential growth. Instead of having to rebuild everything from scratch every time, anytime you build building blocks, things get faster. That's how I like to do things. Also, I'm lazy and don't want to recode everything again. These are the generic components that make up the behavior of visibility. So it's a visibility provider, a visibility trigger, which is the exact same as before, it's just been renamed visibility, and a visibility target. The provider contains the show and hide logic. The trigger provides an on-click property to children through clone element. And the target is going to provide an isVisible prop through clone element. This is a little bit different than what we had before. Content and target have been separated. And this is what that looks like. It blows my mind that modal content, drop-down content, and accordion content are all different, but all of the rest of the logic is exactly the same. Now I can put whatever I want for a button here in any of these 3 components. And this content can be also switched out. If I want a modal that, I don't know, covers half the screen instead of the whole screen, there you go. You just make a new content component. It just has to take an isVisible prop and then do something with it. And like I've showed before, it doesn't need to be named isVisible. It could be named whatever you want. It just needs to take some kind of Boolean prop or a string prop if you want to use finite state machines and control the visibility that way. This is why these building blocks are important, because these are all the same. If I would have just built this visibility thing the first time, then anytime somebody asks me, oh, I need a drop down, I need an accordion, whatever, all I got to do is build this one little piece here. I'm going to build the rest of this logic to go with it. It's crazy. And if you're thinking about over engineering again, is it better to build 3 custom purpose-built solutions? And it's not 3. You guys know you're going to build like 5, 6, 7 of these that are almost identical. Is it over engineering to do this? Or is it over engineering to build one set of building blocks? You're thinking about like how much testing is required for all of these custom built solutions. And they almost have the identical testing. And you're going to miss some things in one test and get some things in another. And it's just going to be how it is. And what's the maintenance overhead of all these? Well, I already know the maintenance cost because you can't scale. Every time you want to build something else, you got to build it from scratch again. And then if anything is wrong in that modal or that accordion or that whatever, you're going to rebuild it from scratch. And then you have a version 2 of it or something like that. If you just built the building blocks, then they're separate and that logic almost never changes. In fact, I don't think I've ever seen the logic change for open, closed. You might have opening and closing, but you can control that in your content component. If you need to have an opening or closing, that's your local. That doesn't have to be from the exterior. That doesn't have to be from the parent. Just basically needs to say, somebody asked you to close. Somebody asked you to open. Please handle this yourself. Here's an invisible prop. Go do whatever you want. And you're also thinking, like, what's the cost of using all of these that have slightly different APIs? Let me guarantee you, I have never seen a project or a component library that all of the props on these similar things are exactly the same. They all have completely separate props. It's crazy. So you're not even having the same API for everyone. That means when you're documenting things, you have to document them over and over again in slightly different ways. Whereas here with the visibility, you can just document it once and it's going to have the same API no matter what. The contract is your button needs to have an on-click, your content needs to take in as visible prop. End of story. And you're thinking, there's magic there. I don't know that those props are being sent, except that those are the same props for 7 or 8 or 9 different situations. So it becomes more obvious to somebody using the code base that after you've done it once, you can do it multiple times. It's already been built that way. This is what's referred to as loose coupling. You build the building blocks and you allow somebody to consume those building blocks and put whatever they want in there, and you don't have to maintain it. So as a library author, I like this kind of stuff because it's not my responsibility. I don't want to maintain all of the stuff that I don't care about. As I said of visibility components, do I care about what content is being rendered? Do I care about modals? No, I don't even know what a modal is. I just need to give an isVisible prop out to something and then let it manage it. I don't care about it. Maybe I need children to give the isVisible prop to, but other than that, I don't care. And on the side of the button piece, the trigger, what does it care about? I need a child that allows me to feed it an on-click. And that's optional. I don't even need that. If the child wasn't there, I just wouldn't render any children. But that's one of those weird kind of situations where I think if you're going to put a trigger there, why not just put a button? But there could be cases where you want to hide the button and you should really hide the trigger with it. So just don't hide the button by itself. And that's a weird situation, but it really just cares about having a child that it can pass an on-click to. That's all. That's all. Doesn't even need to be called on-click. Could be called whatever. It's just more simple to call it on-click because typically it would be a button and a button would take an on-click. And this loose coupling is possible because of context. It allows any component to consume the context from the provider, meaning a child can consume the parent's props without having to even know about the parent. But there's a problem. What if you need to control multiple visibility providers at the same time? Yes. What do you do? A provider can consume the context of another provider. Therefore, you could create a list provider or some kind of single selection state provider and wrap all of your visibility providers in it like you would with an accordion and control them that way. This could be built into visibility provider. If you're thinking like, does that belong in here? Yeah, I think it does belong in there. It makes sense that you would want to control the state of a visibility provider from outside of it. And you want to do that optionally. So you can optionally wrap all of these that you need, like an accordion list or something like that, in some kind of list provider component that then can control the visibility of multiple providers. That's fantastic. I'm going to move on to something else now. Have you ever built a custom select input? I don't think most people have, but I have. And in fact, there is an HTML select input that you could use instead, but typically that doesn't provide as good of a UX experience as you would like, especially in the desktop. And a lot of times when people are asked to build these, what they'll do, and what I've done in the past, is just find some complex library that's poorly implemented with a really strange API. And that's how I build my select input. And it's awful. I hate it so much. And I vowed to never do that again. So the next time this came up, I didn't get to build it, so I had to think about it. I've thought about this for a long time, and I figured out how to make a children-first select input. The way you make a children-first select input is realizing that select input is just a dropdown. It looks something like this. So we have a visibility provider and a trigger. Okay, this is the same as we had before. And in there, we have a select input button. Whoa, everybody hold your horses. This has got a different name on it. That's because it has a chevron. And that's literally the only difference between it and a normal button. It's got a chevron icon. Great. Still has an on-click. And selected item name. So there's some kind of state here somewhere. Okay. And I'll show you how to do that in a bit. Okay, there's visibility target here. We know about that. And drop down content that we know about that too. And then the hide on click. What the heck is this? This is a special thing I added here just to make it a little bit clear, but this hides your visibility when you click it. And if anything gets clicked in that div, it hides it. Perfect. Problem solved. What's interesting about this is that I didn't put the word visibility in the front. And so it's not clear that it's associated with the visibility provider. Yes, I probably should have changed this a bit. What it does is wrap your children and then allow you to hide it on click. There are some other ways to manage this state. There are better ways to handle it. I could just add another component. Again, children first. So you think of children, how can I put a child here so I don't have to build in hiding on click into my dropdown? Because typically you probably want that for other things too. You might want that for a modal or anything else. But just to keep it in mind here, when you do select one of the options on a select input, it would close it. That's the behavior you're looking for. So that's what this is doing in this example. What's also interesting about this is you can render select input as an accordion. You can change the dropdown into an accordion. And now you've got an accordion instead. You're probably thinking to yourself, why would anybody want to select input to render as an accordion? And you have absolutely no clue what crazy things I've been asked to do in my career. It is a normal thing for somebody to ask for a component that is existing to render completely different than it used to. It is not the first time I've seen this. Typically, it would probably be the other way around, that the accordion needs to render in a dropdown. But this is something that comes up, and you want to be building your components, children first, in a way that this is very easy to make a change to. This whole visibility target thing here, the contents of it, of a select input, this could be children here. A select input could take children, and this would be the children right here. You have to put the dropdown yourself, and then your options can display. Otherwise, they're going to display right under it. That might be a better pattern. And you're probably thinking, children, children, children. We've talked about children. It's right here. You got something called children. I'm not going to tell you yet, because there is a related topic that we need to discuss first. And that has to do with this radio group. Now remember this, it took options, and these options had individual sets of bad props. We got around this by using children. So it would look something like this. And this example is really interesting because think of if you had these headings as part of radio group. Now say that you've got a requirement for this one project where, okay, the A is too small, or it needs to be rendered a certain way, or it doesn't fit the styling of where we need it, and so you need to make it bigger or something. Now you're going to add all these props to radio group to handle that, right? Radio group doesn't care about that stuff. And that's why we're using children. Radio group is not rendering these. It's just rendering children. And we are putting these in ourselves because now we can change it as necessary. It is going to scale and change as needed over time. We didn't have to do anything special. In fact, our radio group is super simple now. It doesn't have to render a bunch of radio buttons and reduce the amount of things that we have to test because radio group is so much simpler. And then we can test radio separately. This is such a good design process. And it does fix the problem. And if you're thinking, this is crazy, this actually is a real example of how we fixed something at one of the companies I worked at, where we had this kind of thing happen, where we needed to put these in here, but radio group was rendering radios and they didn't have any knowledge of these. And the choice was, do we want to update radio group to now have all this extra logic to figure out how to render letters and do all the sorting and all that stuff? Or do we want to make it so that we can just do this ourselves? And what we did was say, radio group, hey, if you see children, render children, don't worry about options. Let us do this ourselves. One other thing is that radio group, because it rendered the radio options itself, we had to create this component in the component library because it didn't exist. And it was something that radio group was handling. By making it separate, now we can use it wherever we want. That gives us a lot more power. What about checkbox list, image picker, radio group, and select input? And you're thinking here, okay, I said I'd get back to select input and we got radio group. Why are these together here? It's because they're all the same. They're exactly the same. In fact, I built all these separate before and they are all the same. And it would have been nice to notice this before because I would have felt a lot smarter now when I'm presenting this. I see that they're all the same. It's so clear to me that they're all the same. But because I didn't have the children first mindset when I built a lot of these, I didn't build them that way. What was I really asked to build in this situation? I was asked to build a select input. Okay, so an input that allows for single or multiple item selection. You know what also allows that? An HTML select element. That allows you to have multiple selection. You just put the word multiple on it, and then bam, you got multi-select. But we can't use a select because it's not easily stylable. So we got to find some other set of HTML components that do this for us because select does this for us. I don't have to rewrite logic that's already built into the browser. Is there anything else I can use that allows us to select single or multiple items? Yes, there is. A checkbox, which allows multiple selection, or a radio button, which allows single selection. So you know, it all comes back together. We can use an input with a checkbox or radio type to handle single or multiple selection. And this is literally built into the event. When a radio event occurs, it actually handles differently than a checkbox event, and you can manage that state in a unified way. Any form library that can handle checkboxes or radio buttons already has this built in. It's crazy. So you just use regular inputs, and you've already created a component that is related to these kind of inputs and allows you to manage its state. Now we can make a children first picker. And that looks like this. There's a picker provider and a picker selector. You can probably guess that the provider includes the logic. Yes, it does. And the picker selector. Okay, what is in the picker selector? Okay, an input. So picker selector has the input. And based on what we pass to the provider, we know if it's single or multi-select. And we can, in the selector, choose to render an input of checkboxes or radio buttons, but we don't want to render them on the screen. We want to render them to the DOM so that they can be controlled by some other component. And that's what the selector is wrapping. Children of selector allow us to do this. And this is what that looks like. So here's a styled option. This would be like a select option or something else. A styled option, and it's a span, could be a div, whatever. In this case, it is a span. It takes a role. The role is coming from the picker selector, and that allows you pass in a role of checkbox or radio. And what that does is it hooks in with this aria checked here, and we're also passing an isSelected prop by cloning the children. And now we can control the state of this span as if it were an input. But by clicking this, it also clicks the input because it is children. And something else to keep in mind is the span has styling, and the styles do care about isSelected. If it's currently in a selected state, then the span will render the styles differently than if it was unselected. That's great. We handled it all right here. Now we can create whatever component we want that is selected or unselected. Now, the one thing is this does not work with button because button steals your click event and it does not transfer it through to an input. There are ways to solve that, but in the examples that I've actually built in production, I didn't need to solve that. And this is what a children first picker looks like. So you have your picker provider, you have your selector, and inside the selector is the selected option. It's getting props from the picker selector. And the value is on the picker selector, not on the option, because the option is just click on and off toggle. It doesn't know about a value. A value is what gets pushed through into an on change when this is changed. In this case, it doesn't care or know about any of that stuff. Now it could, but in this case it doesn't. If you look at the picker provider, it takes an on change function and it takes a value. That is just like any regular input. There's one weird piece, the selection type, and that defines the role. So if we pass single, it passes radio. If we pass multiple, it passes checkbox. And then that allows this to be in a checkbox or radio role without having to care about the input. The picker selector cares about the input, and then it has a label that wraps everything. If you click on the option, it clicks on the label. Now that's one way to implement it. There are probably better ways to implement it, and over time, I will create better ways of doing this. Today, this is the way that I've come up with to build this. Either way, it doesn't matter too much. It's still children first, and it allows scaling. I can build whatever kind of options I want, and I can put whatever I want there. Now, I can't really put a button there. I would need to have a custom kind of selector that passes an on-click down here. So maybe I can optionally pass an on-click down here and then handle it that way. There are lots of cool things I can do now that this is children first. You don't have to change your code. Your code could just be like, here's your HTML, done, problem solved. This is actually also implemented. This is another thing that is in production today. Now, I didn't build this one. I created the API. Somebody else built it. But this is in production today. That's really cool. Something else that's very important is that picker provider component actually has no logic. So while it should be a logic component, it doesn't have anything. And the reason it doesn't have anything is because I'm using an input behind the scenes. An HTML input has that logic. I don't have to maintain it. Now, you do have to figure out if it's a radio or if it's a checkbox, how to manage if things are checked or not as a whole. And the way you do that is with a wrapper or some kind of hook or something. The provider doesn't need that logic because it's just like a regular input. It notifies you of changes and it keeps track of a value that is the current value. So how do you control it? You can use hooks. And this is how you would use a hook. And yes, I've created something like this before. It's like you use picker selection, great. And it gives you the on change and the value and you can just pass them straight in. This is the initial value right here. Great. Easy, easy, easy. Super simple. It allows you to control the picker provider as if it were an input with any form library. In this case, we're just using a hook. This does not scale. If you have multiple picker providers, you're going to have multiple hooks. I would use some kind of form library instead, like OneForm. This should resemble now what an HTML select looks like. We've got the API of an HTML select and any kind of controls, it doesn't have to be this, that can control an HTML select. That's great. Universality with the browser. Select input that we built earlier is really just drop down and picker. That's why we went into the radio group, because we needed to define children and put this picker in there. And this is what that looks like. It's children for select input. And let's simplify this a bit. These are the picker components that we've created right here. This picker selector is wrapping a select option. This picker selector is wrapping another select option. So notice each one has to wrap an option, no big deal. And then I added this select option group because if you want to put little tiles in there you go. You can just add them wherever you want. And I did it here for fun. And there's your picker provider. It takes a name, so it hooks into your form library. Simple. Easy. Now let's look at everything together with my library OneForm. And why would I want to put my own form library here? Because it is a children first state manager. meaning it's built children first. Therefore, we can use it and show how you can take a bunch of different children first design patterns and put them together for one select input. And this is what that looks like. Oh man, let's just look at it in pieces. OneForm is a provider component, and it does have a context that it provides. In fact, it provides 7 different contexts. Visibility providers here, we remember these, right? Select input button. This is what was statefully maintained before in the select. Field value. So what is field value doing? It is displaying the value of the field that has a name of color. Simple. So if the field changes for color, then the field value will display whatever that text is, which is the currently selected item. Great. Children first. Now, you've got the visibility target. This is the rest of it, right? Drop down, hide on click, all the stuff from before. And we have a field. Field is coming from OneForm again. What it does is look at children and it looks for the name prop. It captures that. That's what it's going to use for the state segment that it's going to be assigned. And it's going to provide that component with an on change and a value, which are the standard input mechanisms. And because we built this as a standard input, then you can just pass those in. No big deal. And OneForm also knows how to take advantage of radio and checkbox. Those are standard HTML, and it has built-in support for those inputs. Everything else here is the same, but if you click this option, this value will get sent to an on change that was passed to the picker provider from field. And because this name is here, it's associated with that. And then if we go back to this one, it's going to display that green in this field value. Simple. All children first. And if it looks like when you're seeing this, that we're missing props here or we're missing props here and I just hate a bunch of stuff. No, this is what it looks like. This is the actual code. I can run this in production. I have this working right now in a code sandbox. This is the exact code that I'm running myself. It's insane. It's so clean. As long as you understand the contract, you have to understand that this is passing and is visible. And honestly, you don't really care. You really don't care about this contract. I think that's what's most important about what I'm trying to say here. You as a consumer just need to put this content in the target. You don't care that it's passing and is visible prop. Now, if you are making your own content, then you care about the contract. But what will happen is you'll look up visibility target in your documentation. You'll see that it takes props in and then they'll have props out, and the props out would be is visible. All you got to do is build a consumer that takes is visible and just put it here. Problem solved. That's the cool part about all of this. And you could even make it return a data visible property. If you wanted HTML and you want to inline all that stuff, you can do it however you want. The point is that I don't care about that. Therefore, I don't want to see it. I don't even want to know it's there. If I want to build a custom one of these, I'll build a custom one. Typically, you'll only do that in the component library itself. And if you look here, okay, hide on click, all this stuff, you don't have to manage anything. All of it's done for you. It's great. I've been using this in production for well over a year at this point. This pattern works really well. Before we're done, I want you to think about prevention and not cures. Very few people can fix broken systems, and it usually requires somebody that worked on it before. And those people most likely don't work there anymore. If a design scales today, it should also scale in the future. So when you're thinking about prevention, you're going to allow for scalable designs so you don't have to rebuild those in the future or even change them. The simpler you make them, like that visibility one, the simpler it is, the easier it is to scale. I probably never have to rewrite that in my entire life. You want to write evergreen code. If you do it a lot, it'll become second nature. At the beginning, it is very hard to know how to do things children first. I had to figure it out myself. I didn't even realize that what I'm building is something called compound components and that all I've really added is context and changed a little bit of what it looks like. That's it. And as I built more things that way, I got used to it and figured out better ways of building them. If you want other people on your team to build stuff that way too, just have them get used to this. And honestly, you'll end up writing less code anyway. You'll build it once and then never touch it again. What it'll be is that you're building it once and then just consuming it, and you'll get used to it that way. And you want to become familiar with your tools. I came up with children first design patterns because I understood React at a deep level. Compound components was come up by Ryan Florence because he understood React at a deep level. And if you've seen React Router, you'll understand that. You also want to start thinking about organization early. You can avoid a lot of this tech debt if you build with the whole system in mind, rather than looking at individual tickets of work. I end up building things that are custom and purpose-built because I'm not able to figure out from that perspective how to architect a solution for everything. Now, oftentimes, if I build it in an over-engineered way that most people would assume, it ends up fulfilling the future needs of the company literally within the next day. It's one of those things where you build it this way and then it ends up needing to be used. I remember a website a long time ago. I built it where the text could be changed with JSON because I was like, maybe some designer can change the text that way. And I don't now need to manage it because I was building the website and I had a build tool. And I remember even having to argue for why we needed a build tool. Oh my gosh. I came up with this idea of, okay, if all the text is in the JSON, then I just have to manage how it's rendered. That way somebody else can edit the JSON file and I don't even need to worry about it. That was beneficial to us at the time, or at least I thought it would be. And I remember talking about it and my boss was saying, oh, it's like over-engineered. And I was like, okay. What ended up happening was literally the next day, he asked me in his office and he said, hey, I need that site in Spanish as well. And here's the script. And I was like, great. You know what? All I need to do is create a new JSON file and then just make it so that I can swap those files on the build. So I have 2 build steps now, one that builds the English and one that builds the Spanish one. Problem solved. It was because I built it that way. I don't want to encourage people to over-engineer solutions. That solution I made also was useful because I started doing emails at the company and the emails also needed to be in French. So I was hearing things at the company and I was like, this would be useful and valuable. And my boss let me have the time for it. It wasn't like I just went cowboy and built that kind of stuff. The point I'm saying is that even though he thought it was engineering, he thought, it's valuable to at least put it in. It might be fine. And it ended up being useful literally the next day after that conversation. That's not always a typical thing. Sometimes you build something with building blocks and end up not using the building blocks ever. Sometimes projects get canceled. I've had projects where I built this fundamentally amazing technology and then the project got canceled, and so I never really got to use it. Build what you need, but at least take a look at the big picture when you're doing that. Understand that maybe some other team might need that accordion that you're building, and you need to build it in a way that they can also use it, which is just something that happened recently for me. There is a beacon of hope, and that's you. Your architectures might be different than your existing code if you build them children first. But then you can start the conversation today and figure out how you're going to start implementing this in the future. As you do it more, you're going to be able to scale and change with whatever the business requests. And that's fantastic because that's what they want. They want you to be able to change on a dime. They don't want it to take months and months of work to literally rebuild something from scratch just to get it out there. And if you build fewer things and they're testable, that is way easier to get across. You're like, yeah, I have to build this component once and that's it. And then there's your tests. And you can pay me for the time it's going to take to test it, which might even take longer than it took to write the thing. But I only had to do it that one time and not 9, 10, 11, 12 times, 13 times. As you notice, the select input was also a dropdown, which is insane. Oh, wow, how many things are using the same visibility pattern? Think about that when you're building these tools. Back to the very beginning. Why should you care? Because it matters. On a lot of projects, you write code and it becomes what I call instant legacy. Instant legacy means that at the time the code was written, it's already legacy. It's already something nobody wants to work on that nobody can deal with. I've seen this over and over again. Somebody built a very complex solution and now we get to pay for that TED debt for as long as I'm with the company. Man, it never got fixed by the time I got out of there for some of these. It really does matter because bad architecture is an insufficient design and that causes tech debt and you will pay for it. You've probably experienced it too, where you're just trying to do something simple and you got to wait for somebody else to fix a problem that's completely unrelated to your thing that blocks you from being able to get your work done. And maybe that thing causes some other problem and then that causes another problem. And I've had that happen over and over again. It's not just a one-time thing. If you want to know more about OneForm, the docs are right here. I would highly encourage you to at least check out this library, even if you're not going to use it, because I want you to understand how children first design patterns. And I think that can show you how you might implement this kind of functionality in your own applications. But I would also love it if you could use it because I would appreciate any feedback. And I think it's fantastic. I've used it everywhere I needed a form since. I've never used any other third-party library since I wrote it. If you have any questions, there are plenty of places you can contact me. You can also comment on the video. That would be fantastic. Thank you very much for your time. Goodbye.